As we have talked about many application type, but all an ideal amplifier in practical world suffers some imperfections. Let's talk about that. The first one is an offset voltage. When the two terminals of the op-amp are tied together and connected to the ground, what we find that the finite DC voltage exists at the output. The op-amp output can be brought back to its zero voltage by connecting a DC voltage source having opposite polarity and same magnitude as the input terminal voltage. Okay. To overcome this problem, a DC offset ID by capacitively coupling the amplifier. You can also add a capacitor to remove the DC. The infinite impedance at DC. The coupling capacitor will cause the gain to 0 at DC. Input bias current IB is 0.5 IB1 plus IB2. If two current gain are added and the input terminals, the input offset voltage will be IB1 minus IB2. Now these are basically mostly formulas, and the concept lies in the diagram itself that if we assume that there are infinite voltages, infinite current, infinite resistance between the two terminals. However, if that is not the scenario, if there is some voltage and there is some input current going into the terminals, then it will have some input bias currents and input offset currents. Okay. If you consider a BJT, there you will find some currents. However, in MOSFETs, ideally they have infinite voltage, infinite resistance because of the MOS capacitor and the silicon dioxide layer. So in that scenario, you won't get any currents, input currents, but in BJT, one can get or not, may or may not. Okay, the next is